So today we're going to learn about limits and their properties, okay? So we have that if L, M, C, and K are real numbers, and the limit when C approaches to C of f of x, it's equal to L, and the limit when x approaches to C of g of x is equal to M, then the following properties hold, okay? So don't overcomplicate this, okay? So the sum rule, it's going to be basically the sum of both the limits, okay? So you know that the limit of x when it goes to C of f of x is L, and the limit when x goes to C of g of x is M, so it holds. So basically, if you know the properties of functions, you will understand the properties of limits pretty easily, okay? So the difference rule is exactly the same as the sum rule. The only thing that changes is that you have the negative here, which obviously is going to transfer to your result being negative here instead of positive, okay? The product rule works exactly the same way, L times N, because you have a multiplication. Now, you know that in the quotient rule, the only thing that you need to be careful, it's going to be the one that is the denominator. You don't want it to be 0. Therefore, you just need to be careful when M is different than 0. Otherwise, it's going to be undefined, okay? Now, the constant multiple rule, it's a very convenient way. If this is a constant, you can pull out the constant, and then you can just compute the limit of x when it goes to C of f of x, and then you have k times L. The power rule, it's another very convenient rule, okay? Very interesting rule. Please note that the s needs to be different than 0. Why? Because r and s are going to be basically part of the exponent in this case, okay? So the exponent, you don't want it to be a 0 here for obvious reasons, okay? So you evaluate your f of x, the limit when x goes to C of the f of x, and you know that that one is going to be L, but that L is going to be raised to the power of r divided by s, okay? That's why you have this situation, okay? Of course, you need to make sure that this is a real number, otherwise we have other issues, okay? That are not part of this class, by the way. Okay, so the limit of a composite function rule is basically if you have that this is your limit when x goes to C of g of x, and if this one if f of L is going to be the limit when x goes to C of f of x, then you know that the limit when x goes to C of f of g of x is going to be equal to f of the limit when x goes to C of g of x, which you know that this is L, therefore you have f of L, it's going to be the resulting part, okay? I know that the properties look a little bit intimidating, but don't worry, it's going to be much, much simpler. Okay, so let's do the first one. So for this one, you have the a constant multiplying. So what I would do here, I would have that this is equal to 5 limit when x goes to A of g of x. Okay, so you have the 5 here and you have the limit, but this one you already have the information because you know that the limit when x goes to A of g of x is equal to 3, so you know that this is going to be equal to 5 times 3, and you know that this one is going to be equal to 15, and that's pretty much it. Isn't that nice? Please remember to put the limit when x goes to A, otherwise you are going to get penalized all the time, okay? So let's do this one, and I'm going to do it in a separate piece of paper because this one, the notation is quite important, okay? So you have that this is going to be equal to the limit when x goes to A of 6 plus the limit when x goes to A of f of x, everything divided by the limit when x goes to A of g of x. Are we okay with that? So please remember that you need to write the limits, otherwise it's going to be an issue. Actually, you can skip it here because it's already evaluated, but not here and here. Here are super necessary. Okay, so this is going to be equal the limit when x goes to A. Since it's a constant, you have that that's only 6. Okay, you don't have any other function. Here you need to ask yourself, okay, so this plus stays there. Then what is the limit when x goes to A of f of x? From the information that we have, it's 2, so just plug the 2. As you can see, I'm not writing the limit anymore because I already evaluate the function. Okay, in the same way, you have the limit when x goes to A of g of x. You know that what? It's 3, so you have this equation and you know how to add, so this is 8 over 3, and that's it. Okay, so that's for B. Okay, now let's look for C, so this is B. Okay, so now for C, what are we going to do for C? Well, in the same way, let's use the properties. Okay, so you have that this is the same as saying the limit when x goes to a of f of x squared divided by the limit when x goes to a of g of x minus the limit when x goes to a of 3. Okay, so this one you can tell me, oh, okay, so it's only the number square. Yes, what was the number? The number was 2. Okay, so this is going to be 2 squared divided by what is the limit when x goes to a of g of x? Well, we have it here, which is 3. Okay, minus, and then what is the limit when x goes to a of 3? Just 3, right? So you are like, okay, so this is going to be 4 over 0 sad face. Okay, so this is going to be equal to what? Undefined. Okay, so I just write the undefined there. Okay, don't write the sad face, right? I just write it because we don't like the 0 to be the denominator, but that's why. Okay, just remember that. Okay, so moving on, let's move to algebraic methods to solve limits. One of the easiest methods for checking if a limit exists on a function is to check to see if the values exist. Okay, we call it basically the substitution method. Okay, so what are you going to do? Technically, in horrible words, you just plug this number here. Okay, why we can do that? When I plug it here, I know that this is going to be 6 minus 5, which is 1. And when I plug the 3 here, it's going to be 3 plus 1, 4. So you have 1 over 4. Is that a number? Yes. Okay, so you can do it. Okay, so basically this is the best case scenario, the easiest limit that you can imagine. Okay, so you have this situation in case that you don't remember what we did. Okay, so you have 6 minus 5. It's going to be divided by 4, so you have 1/4, and that's it. Isn't that easy? So if you have this substitution method, it's like, oh, super simple. Okay, following the same method, what do you think that we're going to do here? Okay, so you're going to plug basically the -1 here and here as if it was a function. Okay, remember, once you plug the number or you don't have the variable, you don't longer need to write the limit. But once you have the x's, you do need to write the word limit, and the x goes to whatever number you have here. Okay, so you have that this is going to be equal to -1 to the power of 2 minus 3 times -1 minus 4. Then you do this operation, you know that this is going to be 1, this is going to be plus 3, and this is going to be -4. So what do you have? Surprise, surprise, this is 0. Okay, and that's your limit. Okay, by the way, this square, it means that I finished. Okay, so the next one that you have is a trig function. Okay, so what are you going to do? Here you have the limit when x goes to pi over 3 of sine of x. So you treat it as a number because it's just a number. So you have that this is going to be equal to sine of pi over 3. You know your unit circle, and you know that sine of pi over 3 is √3 over 2. And that's it. Okay? Please remember, you do need to know your unit circle from last year. Okay? So the failure of substitution method and indeterminate form is when you need to find another way. For example, if you have 0 over 0, infinity over infinity, then there's a huge problem because we don't know the value. Okay, you cannot conclude when you have this. Okay, we call this the indeterminate form. There are other forms that we will talk about later if we get either 0 over 0 or infinity over infinity. Okay, we're going to use another method. Okay, it's not that, oh, I just gave up. No, there's other methods that we are about to see. Okay, so let's move on to the next page.